So again, welcome to Business Calculus. This is Mathematics 200 at New Jersey City University. So this lectures is the beginning of chapter 12 of our course textbook, which is indefinite integrals. So the whole concept is that from chapter 9, 10, 11, we study the process of finding a derivative of a function. Now, a derivative of a function is given to us and we have to find the original function. And that is the concept of indefinite integrals. So our main objective is to find certain indefinite integrals. And here we start with when we know the derivative of a function, the process of finding the function itself is called the antiderivative or antidifferentiation or indefinite integral. So in this chapter, we are beginning with the concept of integrals. That's a derivative of a function is given to us, and we have to find the function itself, the original function. So for example, if the derivative of a function is 2x, then we know that the function could be x squared. This is what we always do. If they give me original function of x squared, I can use the power rule to find the derivative of x squared, which will be 2x. It will be the 2 times x, the exponent will be 2 minus 1. We know this already. So that's what we read, because the derivative of x squared is 2x. So now it's opposite. 2x will be given to us, and they will say we should find the original function. Now, next, by the function could also be f at s is equal to x squared plus 4. We can see the trick here. What is happening is that if a derivative of a function is 2x, the original function can be x squared plus any constant value, plus, I said, any constant value, because we know the derivative of a constant value is what? Is 0. So which means a question is given to us, the derivative of a function is 2x. Find the original function. The original function can be x squared, it can be x squared plus 4, it can be x squared plus 10, it can be x plus any. So normally we use the symbol c, because c can be any constant value. So the answer will be x squared plus c. Because we know x squared plus 4 will also give me 2x, because we know the derivative of a constant value is always 0. So now it is clear that any function of the form f at s equal to x squared plus c, again, c can be any constant value. Where c is any constant value, we will have the derivative of the function to be 2x. So if a function is given, the derivative of a function is given to me to be 2x, the original function then should be x squared plus c. C can be any constant value. So thus we say that the general antiderivative of f prime at x squared is 2x. It will be f at s equal to x squared plus c. C again is any constant value. Now the process of finding an antiderivative is called the integration. Integration, that's the process of finding antiderivative. The function that results when integration takes place is called the indefinite integral, or more simply we say integral. So we donate the indefinite integral, that is the general antiderivative of a function f at s, by the symbol integral f at s dx. So in our question, if I see a question saying that integrate 2s dx, then I'm going to find the original function, which will be f at s equal to 2s. So here we say to indicate the general antiderivative of a function, f at s equal to 2x. So the expression is read as integral of 2x. So here to be integral. Again, the symbol we have here is called the integral. So integral of 2x with respect to x, because it's dx. integral of 2s with respect to s. So in this case, 2s is called the integrand. The integrand is called the 2s. And the integrate sign is what we have in front, integrate sign. This will indicate the process of integration. And the dx, we already know that from our derivative. Ds indicates that the integral is to be taken with respect to x. Or ds means I'm finding the derivative with respect to x. But here is integral, antiderivative, integral with respect to x. So because antiderivative of 2s is s squared plus c, we can write this as integral 2s ds equal to s squared plus c. So this is how our symbol will be integral 2x dx, which means we are looking for the antiderivative of 2x, which will be s squared plus 6. And there's a formula of doing this, which will be the next lectures we will go through. So we have a question here saying that f prime at s equal to 3s squared, which means the derivative of the function is 3s squared. What is the original function? So here we have to do opposite again. How do I get 3s squared? It means I have s cubed. When I have s cubed, the coefficient come to the front, then the exponent will be 3 minus 1. So s cubed will give me 3s squared. But again, s cubed plus 10, s cubed plus 2, s cubed plus 1, all the answer will be 3s squared. So the answer will be s cubed plus c. So we say that the derivative of the function f at s is s cubed. So the derivative of f at x will be 3s squared. And the 3s squared is what they give it to us, so we need to look for the s cubed. As we said earlier, any constant value, s cubed plus any constant value will give me 3s squared. So the conclusion of the answer will be s cubed plus c, where c is any constant value. So again, why we have s cubed? Because we know the derivative of s cubed will give me 3s squared. We don't have to know it in this form. Again, as we said earlier, there's a formula that we are going to see how to find it. But this is very straightforward. So I know s cubed, the 3 will come, exponent will be in front of the x. Then we subtract exponent from 1. So s cubed, the derivative of s cubed will give me 3s squared. So this will be the integral 3s squared dx. This means we are looking for the antiderivative of 3s squared with respect to dx. So that will give us s cubed plus 6. Now we come into the powers of x formula. So this is the formula we can use. What we just did now, this is the formula that we can use. And we're going to see examples soon. So if I have an integral s to the power n dx, like what we have was 3s squared, etc. It will be x n plus 1 over n plus 1 plus c. So the exponent here, we had 1 to it, then we divide by the exponent plus 1 also. This is very important because we don't want to, so for example, here we say that in the powers of s formula, we say that n cannot be -1. Because what happens if n is -1, then we are going to have our answer divided by 0, which is undefined. So let's see an example. Now we are going to use the formula. Same concept as we did without using the formula. So integral s cubed s dx, I'll change the cube root to exponent of 1/3. Now to find the solution here, I'll use the formula s 1/3 plus 1 divided by 1/3 plus 1. So here we get s 1/3 plus 1 will give me 4/3. So it will be s to the power 4/3 divided by 4/3 plus c. Now trying to find the antiderivative of the derivative of this function here, s 4/3 divided by 4/3. you see that you end up getting s 1/3, s raised to the power 1/3 also. Because you are going to get 4/3 is the same as having the coefficient 3/4. Then we are going to have the coefficient 4/3. So 3/4, 4/3 will cancel each other. Then we have the coefficient as 4/3 minus 1. 4/3 minus 1 will give me 1/3. So at the end, we get s 1/3. So to find the derivative of this function, again, the constant value can be any value because the constant value of derivative is 0. But the derivative for s 4/3 divided by 4/3 will give us s 1/3. So that's the whole concept here. Indefinite integral is we are doing the opposite of derivative. Actually, that's why it's called antiderivative, the opposite of derivative. Previously, in the 3 chapters we study we always find derivative. The original function is given to us, then we find derivative. Now, the derivative is given to us, we have to find the original function. So it's antiderivative, we're going opposite direction. So let's see the next example here. So we have x squared at the denominator and 1 at the top. So we can rewrite this as s raised to the power -2. So integrate s raised to the power -2 dx. 1/s squared is the same as s raised to the power -2. Then from here, we use the formula. So we will get s raised to the power -2 plus 1 divided by -2 plus 1 also. So this is what we get, s raised to the power -2 plus 1 divided by -2 plus 1. So finally, we're going to get s to the power -1 divided by -1, which we can write it in this form, -1/s plus c. And that will be our original answer. Now, if we are looking for the derivative of s to the power -s to the power raised to the power -1, we are going to get s raised to the power -2. So there's other formulas and properties. So the first formula we learn is that if I'm looking for a power rule, there to be s to the power n plus 1 divided by n plus 1 plus c. And let's go back to the formula. That's our first formula in antiderivative. That's the power of s formula. S raised to the power n dx, it will be s raised to the power n plus 1 divided by n plus 1. And we use the example to clarify. So in this example here, the same concept. Here we just rewrite 1/s squared is the same as s raised to the power -2. Then we use the formula s raised to the power -2 plus 1 divided by -2 plus 1. And here we get -1. The top also, the exponent will change to -1. So we get s raised to the power -1 divided by -1. So it's the same as writing 1/x negative plus c. So other formulas and properties, we have a couple of formulas here. Derivative constant, when we have only x, we find the derivative of x is 1. Now to find the integral of 1, it should give us the opposite. So the answer will be x. So I know the derivative of x is 1. Now the integral or the antiderivative of 1 will give me s. Now we also have a constant. Actually, this is what we did previously. We have a formula for the constant and then the function. It's the same as writing the constant value times the derivative of the function. This is what we know. To find the derivative of a constant value with a function, we don't touch the constant value, but rather we find the derivative of the function. So we keep the c as our constant value, then we find the derivative of u at c. Now the same concept here. If you are looking for integral and we have a constant value u at x, first we take the constant value out, then we find the antiderivative of u at s with respect to dx. And also the same thing with the addition subtraction rule, which we cover already. The derivative of u at s plus minus v at s is the derivative of u at x plus or minus the derivative of v at x. Same thing if you are to doing the integral. You find the integral of u at x plus the integral of v at x for both plus and minus. So now we're going to solve some few problems using the few formulas we saw now. So I'm looking for the integral or antiderivative of 4 at dx, where we know that the derivative of a constant value is always 0. How do I get to 4? That means I have some x. So derivative of 4x is 4. So here I can say my answer will be 4x plus c. Let's follow the steps. So first we take the 4 out. Then we have the antiderivative of dx. Now antiderivative of dx we put is the same as saying 1 times ds. And antiderivative, if we have 1, it will give us x. So that's why we have 4x plus c1, which will be 4s plus c. Again, here we take the constant value out. We are assuming we have 1 here, so we know the derivative of x is 1. So if I have 1, to go back to the original function, it should be x. So that's why we have x here. So the second question also, we have a constant value. So we took the constant value down. Then we have a power rule here, s raised to the power 5. So it will be constant value 5 plus 1 divided by 5 plus 1. So that will give us s to the power 6 divided by 6. And the original answer, we open the parentheses. 6 and 4, 2 can go both. We get 4 by 3, s to the power 6 plus c. Now with c, we have the integral s cubed plus 4s dx. So we can separate it into two. We have the integral s cubed dx plus integral 4x dx. Then we use the power rule for the first one, so we get s to the power 3 plus 1 divided by 3 plus 1. Here we take the constant out and we have s. So s raised to the power 1, so we use the power rule again. So we get s squared divided by 2. So here we have s4 by 4 plus c1. 4 is constant. We have 1, so it will be 1 plus 1 divided by 1 plus 1, which will be 2 and 2. Here is 3, so 3 plus 1 divided by, this is the power rule. If I have s to the power n, it will be s to the power n plus 1 divided by n plus 1. So if s to the power 3, then we get s to the power of 3 plus 1 divided by 3 plus 1. And the same thing apply here. We take the constant value out first. We have 1, so it will be 1 plus 1 divided by 1 plus 1. So that gives us s squared by 2. And the final answer will be s to the power 4 divided by 4 plus s to the power 2, s to the power 2 plus c1, c2. And we can represent c1, c2 as c. So this will be our original answer. Now we can also apply application in integral. So here we have a question saying that the sales records at Jaros Technology shows that the rate of change of the revenue, which is the marginal revenue in dollars per unit for a motherboard, is MR equal to 300 minus 0.2x. So you can see that previously, when we are solving a problem dealing with revenue, the original revenue will be given to us, and then we have to find the rate of change of the revenue, or we use the term marginal revenue. But this time, the marginal revenue is given. So this means we have to do antiderivative to get the original function. Now the question says, find the total revenue function. So the question here is asking us, they gave us the marginal revenue per unit of the item to be this. And now we are looking for the original or the total revenue function for the product. Then after that, we find the total revenue if we make 1,000 motherboards sales. So this solution here means we're going to find the antiderivative of 300 minus 0.2x. And this will be our integral 300 minus 0.2x dx. And this will give us 300x minus 0.2x squared. The reason why, 0.1x squared, the reason why, because we have s to the power 1, so it will be s1 plus 1 over 1 plus 1. So we get 0.2 divided by 2 give me 0.1. That's why we have 0.1. Then the exponent 1 plus 1 will give me s squared. Then plus k, constant. And since the units are different, then we leave the answer as it is. Here we can see that the fact that there's no revenue when no unit are sold to evaluate to k. Now here we said that we should set our s to 0, our r to 0, the given 0 equal to 300, 0, 0.10 squared when k is 0. If you solve the problem, we are going to get 0 here and 0 here, so the answer will be k. Now, the total revenue function is this. So we're going to get 300x minus 0.1x squared. So to find the revenue base when 100 items are sold, we're going to, S is 100, so we have 1,000 items were sold. S is 1,000, so we have 300 times 1,000, then 0.1 times 1,000 squared. So we do our calculations, 300 times 1,000 minus 0.1 times 1,000 square. That's our answer. So here we say we can check that the revenue R at S we find in example 7 is correct by verifying the rate of R at S, which is 300 minus 0.2x. And R equal to 0 is 0. Also, the graph can help us check the reasonable of our result. So we know this is the antiderivative 300 minus 0.2x. And then this is the original function. So here they say we should know that R at X passes through the origin, indicating R at 0 equal to 0. Also, we should read both the graphs from left to right, and we can see that R at S increase when MR, the marginal revenue, greater than 0. This will give us a maximum when MR equal to 0 and decreases when MR is less than 0. So this will be the conclusion of our first lectures on indefinite integral. Again, in these lectures, we cover the power rule, the sum rule, and then the constant. So the main thing we learn here is we should understand this first rule. The integral s to the power n dx is equal to s n plus 1 over n plus 1. So we saw the example here. If I have this question to solve, first I can change the cube root to 1/3. That's what we did here. Integral s raised to the power 1/3 dx. So I will say s raised to the power 1/3 plus 1 divided by 1/3 plus 1. 1/3 plus 1 will give me 4/3. So we get s 4/3 divided by 4/3 plus c. Using the formula here, x to the power n will be sn plus 1 divided by n plus 1 plus c. So that's the first formula. And the second is what we learned, the constant. First, we have the integral of dx by itself is the same as s plus 1. Then integral of a constant, which is c, then the function u at x. The c will bring the c out. Then we find the antiderivative of u at s dx. If it's a sum or difference, we find them separately also. So this will be the conclusion of our first lectures on antiderivative or indefinite integral. Again, wish everybody the best and thank you for your time.